A central coolant system on a transfer line or line of individual machines supplies coolant from a central tank through feeder pipes, then returns used coolant to the central tank where chips are dragged out and the fluid passes through a filter. These systems offer unique opportunities to reap the benefits of good coolant management. This Lamb transfer line had been running for 12 years without a thorough cleaning. The coolant feeder lines are plumbed out the side of the main header pipe. This allows sludge accumulation in the header pipe even under high pressure and flow. Dead-end areas in piping are prime breeding grounds for bacteria. This dead end of the main header looked suspicious even at a glance. Evidence of contamination dripped from the seal. After 12 years, the cap came off. With no flow through this area, a tremendous plug of bacteria-laden sludge had packed into the dead section of pipe. This example of sludge accumulation in a high-pressure, clean coolant feed line may seem incredible, but the real shock is how common this problem is. Accumulation such as this harbors so much bacteria that a fresh charge of coolant is destroyed in short order. The end of the pipe was totally plugged, as you saw, but the entire length of the pipe had accumulations on the bottom. Feeders out the side promote sludge in the bottom of the header. The feeder lines were plumbed into the header with stubs protruding inside. This made a thorough roto-rooter job impossible. An ideal plumbing arrangement would have feeders plumbed from the bottom with no protruding stubs inside and would avoid sharp bends to minimize accumulations. This system had some flume leaks which created prime breeding areas for bacteria. The concentrated amounts of the bugs would then re-enter the system through the leak. Hundreds of square feet of area around the machines which drained into the coolant return flumes were made inaccessible to cleaning by welded down grating. All the grating was taken up and revealed several inches of oil-laden sludge and chips underneath, a vast bug farm. Fungus growth covered many surfaces of the machines. Gummy residues had also built up in many areas. Residues can be caused by hard water, tramp oils, and low-quality raw materials in coolant concentrates. The sticky residues on this equipment were unpleasant for operators and caused limit switches to stick on the pallet and rail transfer system. When the central tank was opened up, it was revealed that the filtration tank had been overfilled and had flooded the pit. In fact, what was thought to be a 10,000-gallon system turned out in reality to be a 2,000-gallon system. The overflow created a tremendous dead area for bacteria growth. When the fluid level was high, the overflow contaminated the main tank. Bacteria literally eat up the emulsifiers, lubricants, and corrosion inhibitors out of coolant, thus robbing you of many of its benefits. The foul stink they produce comes after the real damage to the coolant has already been done. The overflow in the pit was pumped out to reveal the worst kind of slimy glop. Bacteria are extremely tenacious. Anything that can lodge and proliferate in a high-pressure feed line grows at an astronomical rate in such an ideal environment as this. This area of the pit behind the dragouts, outside the actual tank, shows how unchecked bacteria growth can take over. And this system had been treated with bactericide and fungicide once a week. No coolant, no matter how good, can stand up to this kind of contamination. The central filtration tank was emptied to access the wedge wire filter screens. Sludge and chips were packed under the drag-out conveyors and in every nook and cranny of the tank. This impeded flow through the system, which caused operators to believe the fluid level was low and encouraged overfilling. In spite of what you may have heard, sludge not only makes its way through filter screens, but actually accumulates behind them. We have found this to be the rule rather than the exception. It is imperative to clean behind the screens. Unless all areas of inoculum such as this are found and eliminated, the cleaning effort is doomed to fail. Many will tell you that what you're seeing now is an impossibility. As bad as this looks, it's easy to let a system slip into this kind of condition when no coolant management approach is employed. This is a common occurrence, and the dirtier it gets, the more discouraging the prospect of cleanup becomes. But the job can be done, and it's well worth the effort.
We got rid of the dead areas that you pointed out. We added some flume lines that were much needed.
This customer followed Master Chemical's recommendations and has saved considerably to date by not having to pump out, and the coolant still tests well within working standards. This savings takes into account the added equipment cost and more expensive coolant concentrate. And of course, the customer benefits from increased tool life, reduced maintenance, and increased operator satisfaction.
Some comments from some of the management are it's flat out done the job. Master Chemical's flat out done a number on it.
Good coolant management can be applied successfully to the largest and most difficult machining operations. The results will significantly improve conditions for your operators and can impact your bottom line more than you might dream possible. Coolant management technology from Master Chemical, the coolant management company.